All right, so now we're going to talk about solving linear equations in one variable. And before we kind of introduce this topic, or an easy way to introduce this topic, is I just want to break down the different words here, okay? So let's start with an easy one. One, we're solving things in one variable. That just means they're going to be one variable, just an x, just a y, just a z, just one variable. Now what's a variable? Well, a variable are those things I mentioned. Variables stand in place of numbers and they can vary, right? So x, y, z, those are our common variables. We can really use any letter. We can also get crazy and throw Greek letters in there like alpha, omega, things like that. In general, we'll use x, y, and z, occasionally some other things. Okay, linear. Things that are linear means they are a graph of a line when we were archographic. And moreover, it means that our one variable, right, doesn't have any weird powers. So it's not x squared or y cubed. There's no square roots. There's no x's in the denominator. Our variables aren't in the denominator. They're just nice and simple. So just x to the first power, y to the first power. Our variable just to the first power, okay? Equations, well, equations have equal signs in them, right? So things like 3 equals x, that's an equation, okay? Sometimes it's nice to talk about what's not an equation. So things that aren't equations are things like inequalities, which we're also going to talk about in this section. So inequalities, I can't spell, are things like x is bigger than 3, right? And then we also just have terms. So terms are things like 3x. Notice that neither of these have an equal sign. An equal sign is sort of the defining characteristic of an equation. And then last, solving. Okay? When we're trying to solve something, when we're trying to get it down to something like x, or our variable, equals a number. Okay? That's different than, say, simplifying. And later on, this difference is going to be really important. When we have an equation, we can solve it. In other words, get our variable is equal to a number. Figure out what value, or values, there may be more than one, our variable needs to be to make the equation true. Simplifying, we do things like simplifying when we're dealing with terms. So here's a term, 3x squared over 6x. I cannot solve this. I can't get x equals a number because there's no equal sign here. What I can do is some simplifying, and I can simplify by canceling where I can. So 3 and 6, I can cancel, leaving me just with a 2 on the bottom. X squared and x, I can cancel, leaving me just with an x on top. So the simplified version of this would be x over 2. Now we're not simplifying yet, but I do want to point out the difference between solving and simplifying because that's going to become really important later on. All right, so we're going to be solving linear equations in one variable. So that's things that might look like this. 4x plus 2 equals 7x minus 3, okay? Now, this is in one variable. The only variable I have running around is x's. This is linear because my x's aren't under a root. They don't have any weird powers. They're not in the denominator. They're just x to the first power, okay? It's an equation. I can't remember if I said this already because there's that equal sign. And so that means we want to solve this. Now, in order to solve this, we're going to use mathematical principles to rearrange until we get x equals a number, okay? So in general, remember that when we're working with equations, we have to keep our equation balanced. In other words, we have to do the same thing on the left side of the equation that we do on the right side of the equation. If we add over here, we need to add over here. If we subtract over here, we have to subtract over here, okay? Multiply over here, multiply over there, etc. So in order to solve this for x, we want to get all of our terms with x's, this guy, and this guy, on one side, and all of our terms without, this, and this, on the other side. So I'm going to take a series of steps in order to do that. I'm going to say I'm going to move my x's over here. There's really no reason why, just because of habit, really. So I'm going to subtract 7x from both sides of this equation. 4x minus 7x leaves me with negative 3x. I still have this plus 2. 7x minus 7x cancels, and I just have a negative 3 on the other side. Okay? Now I'm going to move my 2 to the other side by subtracting 2. So I'll have negative 3x, the 2's canceled, equals negative 3 minus 2 is negative 5. And last, to undo multiplying by negative 3, I have negative 3 times x. I'm going to divide both sides by negative 3. The negative 3's cancel, leave me just with x equals negative 5 over negative 3. I'm going to simplify that a little. Negative, negative is a positive. So my answer is x equals 5/3. Now, what does it mean that x equals 5/3 is an answer to this equation? Well, it means if I take 5/3 and replace both of my x's with 5/3, I should get an equation, equality, the same thing on both sides. So if I do 4 times, we're replacing our x with 5/3, plus 2 equals 7, replacing our x with 5/3, okay? I should get that these two halves, this half and this half, are equal. Let's confirm that, okay? When we add fractions, here we go. I can think of 4 as 4 over 1, and then when I multiply fractions, I multiply numerators. 4 times 5 is 20. 1 times 3 is 3, so I have 20/3 plus 2 equals. Over here, I can think of 7 as 7 over 1. 7 times 5 is 35. 1 times 3 is 3, minus 3, okay? Now, to do 20/3 plus 2, I need to get common denominator. So I'm going to get both of these numbers in terms of thirds. Well, in 2, there are 6/3. 6 divided by 3 gives me 2, so these are the same thing. I'm going to finish out this side. 20/3 plus 6/3 is 26/3. Now on the other side, 35/3 minus 3, I need to get 3 in terms of thirds. That would be 9/3. 9 divided by 3 is 3. 35 minus 9 is 26/3. Notice we get the same thing. 26/3 equals 26/3. That means our variable, when our variable is 5/3, we get equality. If our variable is anything else, if I tried to plug in x equals 2 here, I would not get equality, right? If I plugged in x equals 2, what would I get? I'd have 4 times 2, which is 8. 8 plus 2 is 10. On the other side, I'd have 7 times 2, which is 14. 14 minus 3 is 11, but is 10 equal to 11? No, it is not. So in solving, we're finding the value of x that makes this true, okay? Let's look at a couple more examples of solving. Okay, here's another example. Now, this is an equation, it's got the equal sign, there's only one variable, I just have y's running around, okay? And this is linear because all of the y's are just to the first power. Square roots of y, cube roots of y, y cubed, things like that. So we're gonna try and solve this by getting all of our y's on one side, our not y's on the other, and going from there. Now in this case, the first thing I need to do is I need to get rid of these parentheses so I can start combining like terms. Now to get rid of those parentheses, what am I gonna do? Well, I'm gonna distribute, or I'm gonna take our multiplication and distribute it across what's inside the parentheses. So I'll have -2 times 9. -2 times 9 is -18. And then -2 times -5y. -2 times -5 is +10y. I'm going to distribute the -2 here. -2 times 1 is -2. -2 times -y is +2y equals 2 times 6 is 12. 2 times y is 2y. Now we've gotten rid of the parentheses. Next, what we want to do is collect like terms. In other words, things that are like are going to be smashed together, okay? So here I've got -18 minus 2. Well, if I have -18 and I take away 2 more, I'll be at -20. Here I have 10 y's. I've got 2 more y's here. If I've got 10 of something and I add 2 more, that leaves me with 12 of that thing, so 12 y's. Equals over here, there's nothing to combine, really. Okay. All right, so now we've combined everything that we can on each side of the equal sign. So our next step is we're going to get all of our y's on one side and all of our not y's on the other side. I'm going to move my y's over here. I've added 2y. To undo that, I'm going to subtract 2y from both sides. That'll leave me with -20. 12y minus 2y will be 10y equals 12. 2y and -2y cancel. Now I'm going to move my 20 over. It's a -20 or subtracting 20, so I'm going to add 20 to both sides. -20 and +20 cancel, leaving me with 10y equals 12 plus 20 is 32. Last, I have 10 times y. I undo that by dividing both sides by 10. The 10's cancel, leaving me with y equals 32 over 10. Now, that's an answer, but it's not the most simplified answer. So what do we need to do with 32 over 10? We need to reduce that fraction, okay? So 32 and 10 are both divisible by 2. So if I divide each of those by 2, I'll have 16 over 5. And that's our reduced answer there. My math lab is going to want you to give your answers in simplified or reduced form. Okay? So this equation is true when y is 16/5 and not true otherwise. Let's do other examples. All right, here's our next example. 2x plus 1 over 3 plus x minus 1 over 4 equals 13 halves. This is an equation. It's in one variable, and it's linear because, well, we do have fractions. None of our x's or our variables are in the denominator. Okay? All right, so what can we do with this? Well, don't let the fractions intimidate you. One of the easiest things to do with the fractions is to get rid of them. Okay, so I'm going to look at our denominators, 3, 4, and 2, and I'm going to find the least common denominator, or the LCD, of those three numbers, 3, 4, and 2. That is the smallest number that 3, 4, and 2 will all divide into. Okay? Well, 3, 4, and 2 all divide into 12. In other words, they all divide evenly into 12. 12 divided by 3 is 4. 12 divided by 4 is 3. 12 divided by 2 is 6. The advantage of the LCD is if I multiply both sides of my equation by the LCD, it's going to clear the fractions. Now remember, I'm multiplying both sides of my equation by the same number. That means I'm not breaking any equation rules. Okay. So let's see what happens when we do this. Notice that I put parentheses around this left-hand side. That's to remind myself that I'm taking 12 times this first term and 12 times the second term. I'm going to go ahead and explicitly write that out. You probably won't, or you may not do this, but that's okay. I'm going to go ahead and do that. I'm going to do 12 over 1. That's the same thing as 12. Times this first term, 2x plus 1 over 3, plus 12 over 1 times the second term, x minus 1 over 4. Oops, trying to keep my color scheme there, and that equals 13 over 2, again, times 12 over 1. So all I did is explicitly write out that distribution step. And the reason I did that is because now when we look at each piece of this, right, I have 12 over 1 times 2x plus 1 over 3. Notice that I can do some canceling. 12 over 3 is the same thing as 4. So here I'm left with 4 times 2x plus 1. Technically that's all over 1, but when we divide by 1, we don't really need to write that. Okay. Now for our next term, I've got a 12 on top and a 4 on bottom. Those cancel, leaving me with a 3. So I'm left with 3 times x minus 1. And that's going to equal, over here, I've got a 12 on top and a 2 on the bottom. That cancels, leaving me with a 6. So that leaves me with 13 times 6. All right. Now look, we're left with an equation that no longer has any fractions in it, which is really nice. So from here, we're going to proceed like we did with the last example. I'm going to distribute. 4 times 2x is 8x. 4 times 1 is 4. 3 times x is 3x. 3 times negative 1 is negative 3. 13 times 6 is 60 plus 18, 78. Right? Now I'm going to collect like terms. 8x plus 3x is 11x. 4 minus 3 is 1. That equals 78. Now I've got all my x's over here, so I'm going to move my 1 over by subtracting 1 from both sides. That gives me 11x equals 78 minus 1 is 77. And last, dividing both sides by 11 gives me 77 divided by 11 is 7. So my final answer is x equals 7. Let's do one more example. All right. So for this example, 1/2 times 6y minus 4 plus 9 equals negative 1/5 times 40 minus 5y. Well, I could clear the fractions first by looking for a common denominator between 1/2 and 1/5. But I actually think when I distribute, I'm going to end up with no fractions anyway. Let's see what I mean by that. When I distribute this 1/2, I'll have 1/2 times 6y. Well, 1/2 of 6 is 3, so I'll just have 3y. 1/2 times negative 4 is negative 2. Plus 9, that's 9, equals negative 1/5 times 40. 40 divided by 5 is 8, so negative 1/5 times 40 is negative 8. Negative 1/5 times negative 5y is just positive y. Look at that, no fractions. Now I'm going to collect like terms. So I'll have 3y, negative 2 plus 9 is 7 equals negative 8 plus y. I'm going to move all of my y's to the left. So minus y, 3y minus y is 2y plus 7 equals negative 8. The positive y and negative y cancels. Now I'm going to move my 7 over by subtracting 7 from both sides. That'll give me 2y equals negative 8 minus 7 is negative 15. Dividing both sides by 2 gives me y equals negative 15 halves. I'm going to stop for a minute. Can I reduce that? Nope, negative 15 halves is already reduced. So here's my final answer, negative 15 halves. Okay? All right, now one thing I want to point out is all of the examples that we worked in this video had solutions. In other words, when we worked them, we got our variable equals a number, okay? Turns out that's not always what happens. So in the next video, we're gonna look at what happens when a linear equation in one variable has no solutions, or when a linear equation in one variable has all of the solutions, everything is a solution. And we're gonna compare that to this case when there's one solution.